All right, video on velocity now, right? We got through displacement, and now we're on to velocity, okay? Velocity, this one you've probably heard of before. This one's a little more well known, I suppose. And, I think that that can be a good thing and a bad thing, meaning you can have some familiarity with something and say, I know what it is. Great. But it can also mean there's misconceptions that can pop up. So hopefully we can dispel any of those and get you a rock solid understanding of velocity. Okay, velocity is simply the rate of change in an object's displacement, which is a fancy way of saying if I go a certain distance, if I go a certain displacement in a given amount of time, the faster I do it, the higher my velocity, right? If I travel more distance in a certain amount of time, my velocity is higher. I got to be moving faster to do it. Okay, and this is kind of obvious. Like if I walk somewhere versus run somewhere, right? You say I get there faster if I run. At least I hope so, right? The premise, of course, is your velocity is higher. You're covering more displacement in a shorter amount of time, which means your velocity is bigger. Okay, get an airplane. We use airplanes because they're a lot faster than cars, right? There's nobody driving around going 450 miles an hour. At least I hope not. Okay, we do that because we might value time, right? We might need to get somewhere faster, right? So hopefully it makes sense. Okay. When we think about this, back with displacement, you say displacement is basically from a set point. How far have I gone? And again, it can have directions, so positive versus negative, positive versus negative. You get the idea. Velocity can also, therefore, be positive or negative. And we'll talk about that in a second. Okay. You say to yourselves, I know what this is. It's speed. It's basically speed. With the one extra piece is that velocity is a vector, which means velocity can be negative. Okay, velocity. I know that sounds weird, but velocity can be negative because the negative denotes direction. Okay, so speed can't be negative. Speed is the absolute value of velocity, which means it's always positive. Okay, you get in your car, you hit the gas, the speedometer goes up. Okay, when you go in reverse, your car's speedometer does not go to negative speeds, right? But your velocity would. Okay, your velocity, positive maybe is forward, negative would be backwards, right? Then we could be negative. Okay, and we'll see how this applies. Okay, if you want to be technical, displacement is the integral of velocity, which means velocity is the derivative of displacement. What does this mean? It means it's the slope. If I were to graph displacement and time, the slope of that graph, the change in y over the change in x, would be velocity. Okay, meters per second. That would be your derivative. Do you need to know that for this class? No, but making connections. When you hear this, you go, oh, I know what that is. Okay, it's a rate of change. Velocity denoted as a W. Yeah, makes sense because V for velocity, right? Kind of makes sense. Okay. The typical unit used, not always, but typically, is meters per second. Okay. Meters are the SI base unit for distance. So meters would be what we would default to. And then seconds, of course, is the default for time. So meters per second, a rate of change. Okay. All right. Practice problem. If I say, hey, find the velocity of a person who travels north for 1,250 meters in 200 seconds, all I got to do is take my displacement, so 1,250 meters, divide by my time, 200 seconds. That's all I got to do. So if I look at that, 1,250 meters divided by 200 seconds, I get 6.25 meters per second. Every second, this person is going 6.25 meters north. That's what this is saying. Okay, every second. Do it for 200 seconds. How far do they go? 1,250 meters. Another example. How much time would it take a car that is traveling at 60 meters per second to travel 7,050 meters? Well, this is a little bit harder, right? You're not just dividing numbers. Now you need to think, how do I cancel units out? Okay, and this is why that fence post thing I talk about, right? Drawing things out as like little fence posts. Right? And it's hard to do it on the slides, okay? But the idea here is we're multiplying these fractions, okay? So the meters are going to do what? They're going to cancel out. What are you left with? You're left with seconds, okay? So if I'm left with seconds, hey, that's time. That would answer the question. How much time would it take? Calculate the time. So just under 2 minutes, okay? 60 meters per second is pretty fast, by the way. That's like a football field in about a second and a half, I should say. It's pretty fast, okay? More practice, right? What if I say, how much time would it take a plane to go 4,000 kilometers, and then I give you a speed of 330 meters per second, it's in kilometers. And you say, yeah, so what? You got to be careful because those units will not cancel. Okay, kilometers and meters, yeah, they're similar, but a kilometer is a lot bigger than a meter. So you got to convert. You can either convert kilometers to meters, or you could convert meters per second to kilometers per second. Okay, both work. You pick what works for you. In this case, I decided to just convert the kilometers to meters first, and then that way I can get the meters per second to cancel. Okay, so I get left with seconds again. Okay, so you can see here, kilometers cancel, meters cancel. What am I left with? Seconds. Again, I cannot stress this enough. Like, to me, this is one of the most important things in science, or at least in science education, is you need to understand units. And if you don't write them out, and if you don't try, you're probably going to make mistakes all the time because it's not easy to see these things. So you write them out, and then it's easier to see, oh, this cancels if I do this. Oh, okay, I probably get the right unit. Okay. Again, more practice problems here. Boat is traveling at a constant velocity of 7 meters per second. Travels for 3 days. How far has it traveled? Well, we better convert days to seconds, right? So I take my days, convert to hours first, convert then hours to minutes, right? And then I convert minutes to seconds. Now I'm in seconds. That's good because then that can work. That can jive with my velocity, 7 meters per second, okay? What are you left with? Meters. That's a displacement. That's how far I've gone. And in this case, it'd be 1.814 times. I'm sorry, let's just say it out loud. I don't know why I'm putting it in scientific notation. 1,814,400 meters, okay? Or 1.8144 megameters if you want to use that, but that's not a common unit, okay? So we'll call it quits here because now we're on to acceleration, which is the last one, okay, which is the hardest one to understand. So I'll have a video on that so you can check that out. All right, well, have a great rest of your day. See you in acceleration.